First in Science, Chapter 12, Electricity, Part 2. Topics to be covered: electric power and heating effect of electric current. First, let us understand electric power. It is the rate at which electric energy is consumed in an electric circuit. Now let us understand this definition by deriving its formula. So from the previous classes, we know that power is equal to work divided by time, or P, which stands for power, is equal to W divided by T. Now we learned in the first video that V is equal to W by Q, that is potential difference is equal to work divided by charge. So from here we can write work as V into Q. So therefore power becomes P is equal to VQ divided by T. Now we know that Q divided by T is equal to current, as we know that current is equal to charge divided by time. So power now becomes potential difference multiplied by current, or P is equal to VI. This is just what I have stated in the definition above. Now unit of power, it is watt, and its short form is W. Now 1 watt is equal to 1 volt into 1 ampere, or 1 volt ampere. Also there are some other units of power that is kilowatts and horsepower. 1 kilowatt is 1000 watt and 1 horsepower is 746 watt. So now let us understand the commercial unit of energy. As we know that 1 watt or 1 joule is very small value, so we need a much larger value for a commercial unit that can be supplied in our homes. So electricity that is supplied in our homes, it comes in units. And what is this unit? This is kilowatt per hour. Kilowatt hour. So we know that power is equal to energy divided by time. From here, if we transpose time to the other side, we get the formula that energy is equal to power multiplied by time. Now we know if we take energy to be kilowatt per hour, as we know that 1 kilowatt is 1000 watts and 1 hour is 3600 seconds. So energy becomes 1000 watt multiplied by 3600 seconds, which is equal to 3.6 multiplied by 10 raised to power 6 watt second. So from here we get the value of 1 kilowatt hour as 3.6 into 10 raised to power 6 joules. Now let us solve a numerical based on power. So the question here is that an electric generator rated 400 watts operates 8 hours per day. What is the cost of energy to operate it for 30 days at rupees 3 per kilowatt hour? So here first we will have to find the energy and then we will find the cost. So what we are given in the question is that the power is 400 watts, which can be written as 0.4 kilowatts, and the time is 8 hours. As we know that power is equal to energy divided by time, so by taking the energy to the other side, we can get that energy is equal to power multiplied by time. By putting the values of power and time, we get that energy is equal to 0.4 into 8, that is 3.2 kilowatt hours. Now this is the energy used in 1 day. So the energy used in 30 days is equal to 3.2 into 30, that is 96 kilowatt hour. Now we will multiply this total energy into the cost of 1 unit of energy to get the total cost. Hence total cost is equal to 96 into 3, that is rupees 288. So rupees 288 will be spent on the electric generator. Now let us understand the effects of electric current. There are 3 effects of electric current: heating effect, chemical effect, and magnetic effect. Chemical and magnetic effect, we will understand chemical and magnetic effects in next chapters, and in this chapter we will cover the heating effect of electric current. Now you must have observed that when a television remains on for a long time, it gets heated up. Similarly, if we touch a glowing electric bulb, we immediately withdraw our hand as it is very hot. So this means that when current passes through a conductor, that conductor starts producing heat and becomes red hot. This is known as heating effect of electric current. Now let us derive a formula for heat. Now we know that heat is a form of energy, and we have learned in the earlier section that energy is equal to power multiplied by time. So we can write that heat is also equal to power multiplied by time. Now if we replace the value of power as potential difference multiplied by current, we get the formula that heat is equal to V, that is potential difference, multiplied by I, that is current, multiplied by T, that is time, or H is equal to VIT. Now if we apply Ohm's law to this formula, that is V is equal to IR, and if we replace the value of V as IR in this equation, we get that H is equal to IR multiplied by IT, or heat is equal to current square multiplied by resistance multiplied by time. Now this is nothing but the Joule's law of heating. It states three things. That is, first, heat is directly proportional to the square of current flowing through the circuit. Second, heat is directly proportional to resistance of the resistor. Third, heat is directly proportional to the time through which current flows through the circuit.
Now let us solve a numerical on heating effect of electric current. So in the question, we are given that 100 joules of heat is produced each second in a 4 ohm resistor. Find the potential difference across the resistor. So here we are given that the heat energy is 100 joules, the resistance is 4 ohms, and the time is 1 second. And we have to find the potential difference V. So for this, first let us find the current first. We know from the Joule's law of heating that heat is equal to I square RT. So if we take RT to the other side, we get that I square is equal to H divided by RT. And now removing the square sign, we get that I is equal to square root of H divided by RT. Now we will put the values of H, R and T in the equation and get the answer as I is equal to 5 amperes. Now using the Ohm's law, V is equal to IR, we can find the value of V as 5 into 4, that is 20 volts.
Now let us understand the practical applications of heating effect of electric current. 1. Electric bulb. So in electric bulb, the heating effect is used to produce light. You can see the filament of this bulb. The filament of this bulb is made up of tungsten, which has a very high melting point. Also, this bulb is filled with nitrogen and argon gases to prolong the filament's run. When current is passed through this bulb, a lot of amount of heat is generated through the filament and part of the heat appears as light. Second, electric fuse. So the fuse wire has a very low melting point than the other components of the circuit. So if a larger amount of current flows through the circuit, then the temperature of the fuse wire increases and it melts. This breaks the circuit, and thus the fuse protects the other appliances of the circuit by stopping the flow of high electric current. Now let us understand the other devices which work on heating effect of electric current. These are laundry iron. You can see the heating element of the laundry iron. Second, electric toaster. You can see the heating element of the electric toaster. Third, electric kettle. You can see the heating filament or the heating rod of the electric kettle. Fourth, electric heater. And fifth, electric oven. I hope you have understood the heating effect of electric current with the help of these practical examples. You can also watch part 1 of electricity, in which I have covered current, potential difference, resistance and combination of resistances. In that also I have shown a lot of experiments. You can also watch my other videos of my channel. Please like and subscribe.